So now let's take a look at some examples where we're actually calculating with significant figures. In chemistry, you'll be calculating a lot, and significant figures are important when you show your answer. There are two types of rules we will need to use when we are calculating. There's rules for adding and subtracting, and multiplying and dividing. When you're adding and subtracting numbers, you need to make sure your answer is expressed in the lowest number of decimal places. When you're multiplying and dividing, you need to express your answer with the lowest number of significant figures. Most of the time, you're going to be using the multiplying and dividing rules, but don't forget your adding and subtracting rules and that they are different. Now, before we do some examples, it's important to talk about rounding. There's a lot of situations where you're going to have to do multiple calculations all in one step. Make sure that when you do this, that you are not rounding along the way. If you do so, you're going to have your answer get more and more off from the actual answer. So when you round, perform the calculation. Determine the proper number of significant figures in the final answer. Look at the next digit past the significant digit. If the number is greater than 5, increase that last digit to 1. If the number is less than 5, keep the significant digit. Okay, knowing that, you can see here in the addition, subtraction, multiplication, and division, it gives you some sample problems to look at. For example, notice in the addition and subtraction, look at the answer, unrounded, and then look at how it's rounded right before, or right below. You can see that it's reported the lowest number of decimal places. For example, with addition, this number has 2 decimal places, this number has 4. So even though this is the answer you would get when you punch it in a calculator, this is the answer that needs to be reported to 2 decimal places. Same thing as if we were subtracting. 2 decimal places, 4 decimal places. Since 2 is the lowest number, 2 decimal places is what we report to. Notice in the second example, the second decimal place was a 4. However, since the 6 was there, it's larger than 5, it would round the second decimal place up to a 5. With multiplication and division, you're looking at lowest number of significant figures altogether. So this number has 4, this number has 6. When you multiply, you end up getting this answer, but 4 significant figures is your lowest, and therefore 331.8 is the answer with significant figures. When you multiply and divide, you're also changing the unit. So since it was a centimeter times a centimeter, that's where we get the new units of centimeters squared. Same thing with division. 4 significant figures is our lowest, and therefore our answer is in 4 significant figures. Notice the answer is reported with no unit. Why would that be? When you take a centimeter divided by a centimeter, those centimeters will cancel out. So keep in mind when you're multiplying and dividing, you need to change the units. Let's do some more practice on the next slide. Alright, so let's do some practice here. Go ahead and pause the video and work out these calculations. Then you can hit play to resume. Alright, let's take a look at these answers. Simply by doing the math, you can see the answers right after the equal sign. In the first one, we're adding, and so our answer needs to have the lowest decimal places, which would be 1 decimal place versus 3. And so that's why we round the number to 90.4. Notice the meters is still the unit because when you're adding and subtracting, the unit does not change. For the second one, we are multiplying, and so it's lowest number of significant figures. This number has 3, this has 4, and therefore we were going to take our answer and have it expressed in 3 significant figures, making it 374. Since we're multiplying centimeter times a centimeter, the new units are centimeters squared. In the third one, we are dividing, and so once again lowest sig figs. 4 sig figs versus 2 makes sure our answer is in 2 sig figs. Notice in this one, since 2 sig figs was my number, I look at the third significant digit and notice that it's an 8. That's going to round it up to 24. Since it's a meter squared divided by a meter, that's going to leave my answer in meters, because it can be written like this. Meters squared is the same thing as a meter times a meter, and then divided by a meter makes those two cancel out. Finally, in the last one, we're back to subtraction, and so it's lowest number of decimal places. 1 decimal place versus 2 makes sure my answer is in 1 decimal place as well. Units there would be milliliters. Alright, now let's take a look at some examples where you have multiple operations in one set of calculations. When multiple operations occur, be sure to complete one set of significant figure rules before moving on to the other set. Be careful to avoid rounding errors. An example of this would be when you're calculating a percent error. In a percent error, you take the accepted value minus the experimental value, and then you divide it by the accepted value, and then you multiply by 100. Alright, so you can see in this example problem, we have subtraction in the numerator, and then we have division once that's done. So we have two sets of rules that we have to take into consideration. So let's do the significant figure first for the subtraction. So if I take 8.641 minus 8.43, I end up getting my answer is 0.211 grams per milliliter on the top. Now the next thing I would do is I would divide this. So before I move on, I need to make sure that I have this expressed in the lowest number of significant figures. If I take a look at my two numbers that I subtracted, the first number has 3 decimal places, and the second number has 2 decimal places. So my lowest number of decimal places is 2, which means this number has to be expressed in 2. But here's the thing, if I round this already to 0.21, that's going to throw off my answer when I go to divide. And so here's what I do. I'm going to draw a little bar above the 1, which would be the second significant figure or second decimal place, to remind myself that 2 sig figs is going to be my answer. Okay, so now it's 0.211 grams per milliliter with a bar over that 1 divided by 8.641 grams per milliliter. Alright, I'm going to shrink this so I give myself some more space. If I divide those two numbers, 0.211 divided by 8.641, and then multiplying it by 100, since I'm dealing with a percent error here, I end up getting, my answer is 2.4418 continuing percent. Notice the grams per milliliter cancels out. Now, since I'm dividing, I have to do lowest number of significant figures. The bottom number, or denominator, has 4 significant figures, 8.641. The top, remember, only has 2 because I drew that bar over it. So my answer needs to be in 2 significant figures, and therefore my percent error would be 2.4%. The significant figures and calculating percent error is important because it tells us how accurate and precise our measurements are. Accuracy is defined as how close you are to the true value. In other words, it's how low your percent error is. The lower your percent error, the more accurate you are. An example of accuracy would be like if you're hitting a bullseye when you're shooting a bow and arrow. The target is the bullseye. Precision, on the other hand, is how close a group of measurements are to each other. For example, if you have all your arrows hit the same spot, you'd be very precise, although in this second example you're not accurate because you're not hitting the bullseye. In the third picture, you are both accurate and precise because you're hitting the bullseye as well as hitting it continuously. In the fourth picture, you are not accurate or precise because your measurements are all over the place. Notice, in order to be accurate, you only need one measurement. You were accurate after shooting only one arrow. However, to be considered precise, you have to have multiple measurements. So you had to have at least 3, if not more, in order to be precise.